Bismillah, Alhamdulillah, wassalatu wassalamu ala Rasulillah. This is Calculus 2, Major 2, Term 231. Let us have a look to the exam and solve it together. The first question is about an improper integral and determine whether the integral is convergent or divergent. Evaluate the integral if it is convergent. So we know that if we have negative infinity, or infinity, we have to write the integral as a limit. So integral from negative infinity to negative 1 of x squared plus x over x cubed would be equal to the limit. We replace negative infinity by a letter, t or b or whatever, and take this letter to negative infinity if we replace it by negative infinity, and to infinity if we replace it by infinity. So now this is a proper integral. We evaluate and then find the limit. Well, to evaluate the integral x squared plus x over x cubed, I have division quotient here, so I cannot distribute the integral, so I have to do something to rearrange this integral. I need to use this fact that if I have a plus b over c, then I can write it a over c plus b over c. So x squared plus x over x cubed, I can write it as x squared over x cubed plus x over x cubed. And x squared over x cubed would be 1 over x, and x over x cubed would be 1 over x squared when you subtract the power 3 minus 2 and 3 minus 1. So to evaluate the integral, I will write them. Well, 1 over x, the integral is ln x, so I keep it as it is. And 1 over x squared, I write it x to the power negative 2. Now this would be the limit t approaches negative infinity of the integral of 1 over x is ln absolute value of x. The integral of x to the power negative 2 is x to the power negative 1 if you add 1 to the power over negative 1. I can write this as minus 1 over x, bringing x to the power minus 1 down, so it would be x. So I'll have negative 1 over x from t to negative 1. Now I should replace x once by negative 1 and then by t. So I'll have the limit of ln absolute value of negative 1, which is 1. Ln 1 is 0. So I'll have minus 1 over negative 1. So it would be positive 1. So if I replace x by negative 1, I'll have 1. Then minus, let us replace x by t. So I'll have ln absolute value of t. And this minus would be multiplied by this minus, and I'll have plus 1 over t. And now I can replace t by negative infinity. Well, if you replace 1 by negative infinity, there is no t, so limit of 1 is 1. 1 over negative infinity, that's 0. Ln negative infinity, absolute value, would be ln infinity. And ln infinity is infinity. So I'll have negative infinity plus 0. So in fact, I have negative infinity. You know, the graph of ln is like this. So this means that when x goes to infinity, ln goes to infinity. Okay? So ln infinity is infinity. And I have minus sign, so it would be minus infinity. So the integral equals negative infinity, so it is divergent. Convergent means it would be a number. It wouldn't be negative or positive infinity. Find the exact length of this curve. Well, he gave me that x is between 1 and 2. And I have two definitions for L, which is the integral of ds. And ds is 1 plus either dy over dx or dx over dy squared dy. I have x, I'd like to work with x here. So x would be from 1 to 2, and I'll have here dy by dx to the power 2. And I have y in the question. The equation is solved for y. So, of course, it's much, much easier to work with this formula. I'm not sure whether we can evaluate it using the other formula, because how to solve this for x. Anyway, so it would be from 1 to 2, square root of 1 plus. Well, what is y prime? Let us find y prime here, the derivative, which is dy by dx. Well, this is, I have 1 over 3, that's a constant. And the derivative of x cubed is 3x squared. So in fact, I'll have just x squared. And for this one, I have 1 over 4, that's a constant. And the derivative of 1 over x is negative 1 over x squared. That's important. Derivative of 1 over x, that's a rule, is negative 1 over x squared. Of course, you can write it x to the power minus 1 and then simplify until you reach this formula. So that's y prime. I have to take y prime square. So y prime square would be x squared minus 1 over 4x squared to the power 2. And this would be x to the power 4 minus 2 times x squared times 1 over 4x squared. So x squared times 1 over x squared would be 1. X squared will be cancelled with x squared, and I'll have only 1 over 4. Then plus 1 over 16 x to the power 4. This is the square of the second term. So in fact, I'll have x to the power 4 minus 2 times 1 over 4, which is negative half, plus 1 over 16x to the power 4 dx. And if I add 1, I'll have plus half. So I'll have x to the power 4 plus half plus 1 over 16x to the power 4 dx. But if you look here, these three terms came from the square of these two terms. So these three terms are exactly the same, except for minus half, I have plus half. So I can easily understand that these three terms give a perfect square, which is x squared plus, instead of minus, 1 over 4x squared to the power 2. So if you square this, if you expand this, you will find these three terms as we did here. Now, the square root cancels with 2, and I'll have integral from 1 to 2 x squared plus 1 over 4 x to the power 2. So the integral of x squared is x cubed over 3 from 1 to 2 plus 1 over 4, I can take it out. And I have just seen that the integral of 1 over x, the derivative of 1 over x squared, the derivative of 1 over x is negative 1 over x squared. So the integral of 1 over x squared would be negative 1 over x. So you can just do that easily. And even I can take this minus outside. So I'll write it here. And here I'll have plus. So this formula, we used it when we find the derivative of 1 over x. And also the integral of negative 1 over x squared should give you 1 over x. Or you can just write it x to the power negative 2. I believe we just, yeah, we did it here. So see, plus x to the power negative 2, the integral is negative 1 over x. Okay. So we will have 1 over 3 times 2 to the power 3 is 8, minus 1, that's 7. Then minus 1 over 4 times 1 over 2 minus 1. So it would be negative half. So it's 7 over 3 plus 1 over 8. And you can add in the calculator if you like, or just add here these two terms and you will get 59 over 24. So that's the answer. Set up only, but do not evaluate an integral for the area of the surface. Well, the area of the surface S is the integral of 2 pi y or 2 pi x. It depends whether it's about x-axis or y-axis. About x-axis, the formula is 2 pi y times ds. ds is 1 plus. Again, it could be dy by dx or dx by dy squared times dx or dy. Since x here is changing, so I'll work with x, and I'll have x from 0 to 2 here. And so I have dy over dx all square inside the root. So let us find y prime. Y prime would be 4 times x plus 1 to the power 3 times the derivative of x plus 1, which is 1. So the formula would be from 0 to 2 pi. Now y has to change because I have dx, so I have to write it in terms of x. So I have 2 pi, and y I write it x plus 1 to the power 4 from here, and then square root of 1 plus the derivative squared. Well, if you square 4, 16, and x plus 1 to the power 3 raised to the power 2, we multiply 2 times 3, and we have 6 dx. So this would be the integral, setting up the integral, and that's all what the question needs. Write out the form of the partial fraction decomposition. Well, to write out the form and do not determine the numerical values of the coefficients, then the numerator is not important here. I need to look carefully to the denominator and try to factor. Well, x squared plus 1 is irreducible quadratic factor. I cannot factor it. But here, what if I take x squared as a common factor? So I'll have 2x squared plus 5x plus 2. And now this trinomial, I may factor it. So the question would be 17x squared plus 9 over, I have x squared. And factoring these three terms, I'll have 2x and x here. And then plus 2, so plus 2 and plus 1. I have 2 and x plus 4x, 5x. So that's the factored form. And I have x squared plus 1, which is an irreducible quadratic factor. I have x squared, so I write a over x plus b over x squared. This is a repeated linear factor, so we do like this. 2x plus 1 is not repeated and it is linear. X plus 2 also is linear and it is not repeated. And finally, x squared plus 1, which is an irreducible quadratic factor. I have here to write a linear function. So ax plus f, this will do, and that's the answer. How to evaluate tan inverse? Well, you should know that evaluating tan inverse, sine inverse, cosine inverse, all of the inverse functions, we should use integration by parts. And we should use u equals tan inverse. That's the only choice we have. And dv to be dx. So this integral, we are changing this integral to u times dv. Okay, so we need to find the derivative of u. Derivative of tan inverse is 1 over 1 plus u squared. So 2x squared or 2x all to the power 2 or 4x squared times the derivative of 2x, which is 2, So this would be du. And of course, the integral of dv is v, and the integral of dx is x. Now we know the formula of the of the integration by parts. Integral of u dv is equal to uv minus integral of v du. So if I call this integral I would be equal to uv. So multiply u times v. So x times tan inverse 2x minus integral v du. So multiply v times du. So I'll have 2x over 1 plus 4x squared dx. And let me call this integral double I and try to solve it here. So how to solve this integral? Let us try substitution. 1 plus 4x squared, if we take it u, what is the derivative? The derivative is 8x. Well, I have 2x, so I need to multiply by 4. So I'll have 1 over 4 because I multiplied by 4 integral 4 times 2 or 8x dx over 1 plus 4x squared. So now by taking u as 1 plus 4x squared, du would be 8x dx, and this integral would be du over u, and it would be ln absolute value of u or absolute value of 1 plus 4x squared. So the answer would be x times tan inverse 2x minus 1 over 4 ln absolute value of 1 plus 4x squared plus c, and that would be the answer. Well, I have 2 minus sine theta squared. Squared inside the integral leave me with one choice only, to expand. Or take what is inside u, but the derivative is not outside. So expanding this, I'll get 2 to the power 2 is 4 minus 2 times sine theta times 2 is 4 sine theta plus sine square theta. Well, everything is okay here. I can find the integral of 4 sine theta, but sine square, what to do with it? Well, sine square, I have to write it as 1 minus cosine. That's a formula, 1 minus cosine 2 theta over 2. Whenever you have sine square, you can change it to 1 minus cosine 2 theta over 2. So this integral would be, the integral of 4 is 4 theta, and the integral of sine is cosine, or actually negative cosine, and sine square, so this from 0 to pi over 2, and the last integral I will write it 1 over 2 minus half cosine 2 theta d theta. So here I'll have 4 times pi over 2, that's 2 pi. Cosine pi over 2 is 0, so that's it, minus, replacing theta by 0. Well, this is 0, and cosine 0 is 1, so I'll have minus 4. And now here, the integral of half is half theta minus half. Integral of cosine 2 theta is sine 2 theta over 2, or I just write it here 4, from 0 to pi over 2. So I have 2 pi minus 4 plus. If I replace pi over 2, theta by pi over 2, I'll have half times pi over 2, and that's pi over 4. And sine 2 pi over 2 would be sine pi, which is 0. So minus, replacing theta by 0 would be 0. and there is another minus, so this would be plus. Sine 0 is also 0. So that's the answer. 2 pi uh, minus pi over 4, minus 4 plus pi over 4. I can leave it like this, or you can add these two and having 9 pi over 4 minus 4, because this is 8 over 4 plus 1 over 4, 9 over 4. Evaluate the following integrals. Well, you should know that whenever you have this form, we can try to use substitution, usual substitution, but the derivative is 2x and I don't have 2x in the numerator. So I have to use the trigonometric substitution. If I have square root of a square plus x square, then I should take x as a, which is the square root of 25, which is 5, tan theta in this case, because I have 25 plus x squared. There are three roots. Please go back to the section of trigonometric substitution and study them. So x is 5 times tan theta, so dx would be 5, and the derivative of tan is secant square theta d theta. And I need to change now this integral from x to theta. So this integral would be equal to, well, dx is 5 secant square theta d theta. And let me check, this square root will be equal to what if we replace x by 5 tan theta. So this would be plus x squared would be 25 tan square theta. And if I take 25 as a common factor, then I'll have 1 plus tan square theta. And this 5 will come out, okay? 20 square root of 25 is 5. And 1 plus tan square is secant square. So square root of secant square will give you secant theta. So in fact, I have here secant theta d theta. Now 5 cancels with 5, and secant square cancels with secant, and I'll have only secant theta d theta. Now, what is the integral of secant theta? Well, we have it, and we know we should memorize the integral of secant theta because it is somehow long to find it, okay? Long in this place. So I'll just use the definition. It is len secant, I mean the formula, integral secant is len secant theta plus tan theta plus c. And now I need to change back to go back from theta to x. So x is 5 tan theta. So tan theta is x over 5. So if I have an angle theta, tan, which is opposite over adjacent, this is the opposite, it should be x. This is the adjacent, it should be 5. And then the hypothesis, the hypotenuse would be square root of x squared plus 5 squared, which is 25. And that's the same radical in the question. So the answer would be len. Now, what is secant theta? Secant theta is the opposite of cosine. Cosine adjacent over hypotenuse, so secant would be hypotenuse over adjacent. So it would be square root of x squared plus 25 over 5. This is secant theta plus tan theta. Tan theta is x over 5 plus c, and this would be the final answer. Finally, find this integral. Well, the degree of the polynomial in the numerator is 2, in the denominator is 1. Whenever you have something like this, you need to use long division. So you start by dividing x squared by x. When you divide x squared by x, you subtract the powers, it would be x to the power 1. So I have x. Now multiply x times x minus 1. So x times x is x. X times minus 1 is negative x. Sorry, x times x is x squared. Now I need to change the signs of the second line. And now I need to add. So x squared minus x squared will be cancelled, and I'll have x plus x, that's 2x. I do the process again. I divide 2x by x. If you divide 2x by x, x cancels with x, and you will have 2 left. So now multiply 2 times x minus 1. So I'll have 2x minus 2. Now again, change the signs of the second line and add. So always these will be cancelled. And I'll have here 2. That's the remainder. So I can write this integral as the quotient, which is x plus 2, the answer, plus the remainder, which is 2 over x minus 1 dx. And now the integral is easy. Integral of x is x squared over 2. Integral of 2 is 2x. And this is 2 times ln absolute value of x minus 1 plus c. This was the last question. I hope you enjoyed solving this exam with me.